The planet Neptune is not what you think. Almost everyone is wrong about Neptune because almost everything you were taught in school about this planet is wrong. You were likely told it is a gas giant, just smaller, colder version of Jupiter. Or if your textbooks were newer, you were told it is an ice giant, a frozen, dead world sitting silently at the edge of the solar system. Both of those descriptions are misleading. Neptune is not a ball of gas, and it's certainly not a frozen ball of ice. Beneath those serene blue clouds lies a terrifying reality of physics pushed to its absolute breaking point. It is a world of burning black ice, raining diamonds, supersonic winds, and a captured moon that orbits backwards. We tend to ignore Neptune because it's so far away, a lonely outpost at the edge of the darkness. But if you strip away that calm blue exterior, you find a planet that is violent, hot, and churning with secrets that defy our understanding of how the solar system works. So, let's dive in. To understand the mystery of Neptune, you have to understand that before we ever saw it, we calculated it. Neptune holds a unique title in history. It is the only planet discovered by math before it was discovered by a telescope. In the early 19th century, astronomers were tracking Uranus and they noticed something was wrong. Uranus wasn't following the path that Isaac Newton's laws of gravity said it should. It was wobbling. It was slowing down and speeding up as if something massive and invisible was tugging on it from the darkness. Two mathematicians, Urbain Le Verrier in France and John Couch Adams in England, independently began working on the problem. They didn't look through telescopes, they looked at equations. They predicted that a massive planet must exist further out, and they pinpointed exactly where it should be. On September 23, 1846, the German astronomer Johann Galle pointed his telescope at the exact spot Le Verrier predicted, and there, less than 1 degree from the calculated position, was a tiny blue dot. It was a triumph of human intellect. We had found a world using nothing but ink and paper, but knowing it existed was one thing, understanding it was something else entirely. For the next century, Neptune remained just a fuzzy point of light, keeping its true nature hidden until we finally mustered the courage to go there. In the entire history of human spaceflight, we have only visited Neptune once. And visited is a generous word. We did a drive-by. In August 1989, NASA's Voyager 2 spacecraft hurtled past the planet after a 12-year journey. It had a window of just a few hours to take pictures and gather data before flinging itself out into the interstellar void forever. Before Voyager arrived, scientists expected a frozen, silent graveyard. Sunlight at that distance is 900 times dimmer than it is on Earth. Without significant solar energy to drive weather systems, the atmosphere should have been stagnant, perhaps even clear and motionless. But that's not what we found. Voyager sent back images of a planet that was alive, violent, and churning. We saw a massive storm, the Great Dark Spot, an anticyclonic system large enough to swallow the Earth whole. It looked similar to Jupiter's Great Red Spot, but with a terrifying twist. When the Hubble Space Telescope looked at Neptune just 5 years later in 1994, the Great Dark Spot was gone. It vanished. Jupiter's storm has raged for centuries, but Neptune's storms are transient, appearing and disappearing with a volatility that suggests the atmosphere is moving at an incredible pace. This discovery created an immediate paradox that scientists are still trying to unravel. How does a planet so far from the Sun, receiving almost zero energy, possess the most energetic weather in our neighborhood? The weather on Neptune isn't just fast, it's supersonic. Voyager measured winds screaming at over 1,200 miles per hour. These are the fastest winds ever detected in the solar system. Faster than sound, faster than a fighter jet. This defies logical intuition. On Earth, our weather is driven by the sun. Heat energy creates pressure differences that move air. So, logic dictates that the further you get from the sun, the less energy there is, and the calmer the winds should be. But Neptune breaks this rule. It receives the least solar energy, yet has the highest wind speeds. The answer to this wind paradox forces us to abandon the idea of Neptune being a frozen world. If the energy isn't coming from the sun, it has to be coming from the inside. Neptune is a heat engine. It radiates more than twice as much energy into space as it absorbs from the sun. There is a furnace burning inside this planet, but unlike a star, this isn't nuclear fusion. The heat is likely left over from its violent formation 4.5 billion years ago, trapped deep inside, slowly escaping. But there's another theory too, the Kelvin-Helmholtz mechanism. This suggests the planet is slowly contracting, falling inward on itself under its own massive gravity. This crushing friction generates incredible amounts of heat, boiling the atmosphere from the bottom up. To truly understand what this internal heat does to the planet, we have to go down, and this is where the ice giant label becomes confusing. When astronomers use the word ice for Neptune, they're talking about astrophysics and chemistry, not temperature. They mean elements like water, ammonia, and methane. They don't mean ice cubes. If you were to descend into Neptune, you wouldn't land on a solid surface. In fact, you wouldn't even splash down into an ocean, at least not in the way you understand it. As you sink through the hydrogen and helium atmosphere, the pressure begins to crush you. The temperature rises drastically. At a certain depth, the distinction between gas and liquid vanishes completely. You enter a state of matter called a supercritical fluid. Imagine an ocean of water, methane, and now ammonia that is hot, dense, and behaves like a liquid and a gas at the same time. This is the mantle of Neptune. It is a scorching, electrically conductive soup that makes up the majority of the planet's mass. The deeper you go, the hotter it gets, reaching thousands of degrees. This isn't a frozen world. It is a hot fluid planet disguised by a cold jacket of blue clouds. And deep inside this supercritical mantle, the laws of physics start to produce something that sounds like pure fantasy. As we go deeper, about 4,000 miles down, the pressure becomes millions of times greater than the atmospheric pressure on Earth. The temperature climbs to nearly 7,500 degrees Fahrenheit. In this hellish environment, the methane molecules, which are made of carbon and hydrogen, get torn apart. The pressure is so intense that it squeezes the isolated carbon atoms together. They don't just clump up, they crystallize, they turn into diamonds. We are talking about real diamonds, likely millions of carats in size, raining down through the mantle like a hailstorm. For years, this was just a mathematical theory, but scientists have recently validated it. Using high-powered optical lasers at the SLAC National Accelerator Laboratory, researchers shock-compressed plastic to recreate the pressure of Neptune's mantle. They watched, for a fraction of a second, as nanodiamonds formed right in front of them. On Neptune, this happens on a planetary scale. These diamonds sink through the fluid layers until they reach the core, and this process, this diamond rain, actually helps explain the heat mystery we talked about earlier. As the heavily diamonds fall, they generate friction against the surrounding fluid. That friction converts gravitational energy into heat, essentially adding fuel to Neptune's internal engine and keeping the planet churning. So what happens when you hit the bottom? Does Neptune have a rocky core like Earth? Well, sort of, but calling it rock implies something stable and familiar. The center of Neptune is likely a small, rocky nucleus, but it is wrapped in a shell of something remarkably strange. At these extreme depths, water stops behaving like water. The pressure is squeezing the oxygen and hydrogen atoms so hard that they form a bizarre state of matter known as superionic ice. Superionic ice is black, it is hot, hotter than the surface of the sun, and it is solid. The oxygen atoms are locked into a rigid crystal grid, but the hydrogen atoms flow freely through that grid like a liquid. This makes the ice electrically conductive. This black, hot ice is likely what generates Neptune's magnetic field, and because this fluid shell is constantly moving and sloshing around, Neptune's magnetic field is a mess. It is not aligned with the planet's rotation like Earth's. It's tilted at a frantic 47 degrees and offset from the center. It's a chaotic magnetic shield generated by a core of black ice that burns at thousands of degrees. But the weirdness of Neptune isn't confined to its interior. If you look just outside the planet, you find Triton. Triton is Neptune's largest moon, and it's a complete anomaly. In a solar system where almost everything rotates and orbits in the same direction, Triton orbits Neptune backwards. This is called a retrograde orbit, and it tells us a violent story. Moons that form alongside their planets orbit in the same direction. The fact that Triton goes the wrong way means it didn't form there, it was captured. Triton was likely a dwarf planet from the Kuiper belt, similar to Pluto, that wandered too close. Neptune's gravity snagged it, likely destroying Neptune's original moon system in the process. This capture was catastrophic, melting Triton's interior and leaving it with a surface of frozen nitrogen. Today, Triton is one of the few geologically active worlds in the solar system. Voyager 2 spotted geysers erupting from its surface, spewing nitrogen gas 8 kilometers into space. It is a zombie world, captured and enslaved by Neptune, slowly spiraling inward. Millions of years from now, Neptune's gravity will rip Triton apart, shattering it to create a ring system that will rival Saturn's. So, when you look at that pale blue dot at the edge of our solar system, don't think of it as a boring frozen leftover. Think of it as a dynamic laboratory of extreme physics. Neptune is a world discovered by math before it was seen by eyes. It is a world where winds break the sound barrier, where the ocean is made of hot, dense fluid, where the rain is made of diamonds, and where the ice is black and burns at thousands of degrees. It is a gravitational monster that captures dwarf planets and forces them to orbit backwards. We have only glimpsed this reality once, over 30 years ago. The data from Voyager 2 teased us with these mysteries, but we have never gone back to verify them. The technology to send an orbiter there exists, but the mission hasn't been flown. Until we return, Neptune will keep its deepest secrets, hiding its fiery diamond-filled heart beneath a mask of serene blue clouds. Join us next time as we explore more mysteries of the universe.